Hey kids, here we are continuing. This is lesson 10, page 2 in module 4. And it just was too much information in this lesson to get one video without getting cut off or having it too long. So we're doing 2 videos. So part 2, here we go. This is starting with number 3. Circle the expressions that give the same product as 4/5 of 7. And again, if our objective is to compare and evaluate expressions with parentheses, the action of the parentheses is to force you to solve this first. So if they move them around, how does it impact how you can solve these? So that's really the question on this one. Also, there's kind of a weird thing, not gonna lie. There's a little discrepancy between what the key has and what I'm going to show you. So you can ask your teachers about it if you have a question, but I think I can prove that I'm right and the answer key has a mistake. So let's get started. If we have 4/5 of 7, now remember that we know a lot about math now. So I could take 4 times 7 over 5, okay? Now everything that I need to circle here has to be able to get me something like this. Now, you know, because of the commutative property, I could also have 7 times 4 over 5. Those are equal. I can put the equal there because they're equal. So let's check out what our options are, and then we can discuss, which is what you're supposed to do, discuss why you're right. Okay, so for the first one, 4 divided by 7 times 5. Now I have to solve this first. It has to be solved because it's in parentheses. So if you solve it, then you have 4 divided by 35, which is not the same as 4 times 7 over 5. So this is not one that's going to be solved. Now, I'm going to skip this one for now. What if I have 4 times 7 divided by 5? Now, here's a 4 times 7 divided by 5. So I'm going to circle this because if I have 4 times 7, I can use this bar as a division sign. And that is the same as my expression here. So this is okay. Good. Thumbs up. Okay, now how about this one? I have 4 divided by, it's almost the same as the previous one. It's 5 times 7 instead of 7 times 5. It's still going to give us 35. And that is the same problem that I have in the first one. So I know that that is not going to be the same as this expression. Here I have 4 times 7/5. So if I have 4 over 1 times 7 over 5, because of the commutative property, I know that I would end up with 4 times 7 over 5. I can move the 5 here, I can move the 5 there. And it's still 4 times 7 over 5. This is also equivalent, and I would get the same product. How about this one? 7 times 4 over 5. 7 times 4 over 5. Well, look, that is the same as our previous expression. We just shifted our factors on the top. This is also, it has the same value. Okay, now let's come back to this one. In older editions, which is this is a new print because this is like this year's workbook, but it used to be smashed up against this one. So it's almost like they didn't even realize it in the key, and so they didn't circle it in the key, and they don't have it circled in the work part. But if you set this up, if there are no parentheses here, you have to solve from left to right. So it's like it's 7 divided by 5 times 4. Well, that's the same thing that I have here. So if this is equivalent, then this is equivalent. So I'm going to circle that, and I'm going to the mat on this one. And I think I'm right, and the answer key is wrong. And they've made mistakes before, so nobody's perfect. I'm not perfect. But anyway, I think this is right. And if you are not in my class and you go to your teacher and you say, look, I was watching something online, and she said, like, you need to be able to explain why you are right, because 7 over 5 times 4 is still 7 times 4 over 5. And you just tell your teacher, that is the same as this one. We're just moving the factors around because of the commutative property. You should be able to rationalize it and explain it, okay? So basically, in your explanation, we can use the commutative property, to change the order of the factors. The order of the factors. And so that is your explanation as to why we have so many that are equivalent to 4/5 times 7. Okay, now I hope that's clear and I hope that's helpful because it's probably the weirdest one in this lesson. Okay, number 4, use less than, greater than, or equal to make true number sentences without calculating. I know you guys love to do mental math and you don't like to show your work, so here is your thing. This is what you love, right? You do have to explain your thinking though. Ha ha ha, teacher wins. Okay, so look at both sides of the equation, okay? This is going to have a symbol in it to balance the values. So what do I have here? I have 3 times 2/3, okay? What do I have here? Oh, look, you have 4 times 2/3 and more, okay? So clearly, they could have put 3 times 2/3 and left it with 4 times 2. This side is more, the 2, okay? The 2, the greater, the mouth, this is the greater value. This has less, okay? Now explain how you know, because 3 times 2/3 is already less than, THAN, 4 times 2/3, okay? And so this 4 times 2 just makes it even bigger, or makes the left side even bigger. Okay, so just write out a little something. You do have to explain. Do not leave a big white space here. It's going to be glaring that you didn't do the work if you leave that blank. Write an explanation. Okay, how about the next part? They've got 5 times 3/4 in parentheses and 5 times 3/4 in parentheses, which means that that part of the equation, it balances out evenly. Therefore, what if I just take it off? It's like a football game that you play the whole game and you end up at a tie. And then they go to overtime. It's like you're just erasing the whole first part of the game because now the overtime is just going to decide it. So you take it away. It doesn't matter. Eliminate it. Work with what is left. Okay? So compare only 2/5 to 2/7. Okay? Now we're thinking. If I have 2 out of 5 parts, that's almost half. But if I have 2 out of 7 parts, that's way less than half. Okay? 7ths are smaller pieces. If I had 1 donut and I cut it into 5 pieces and I get 2/5, I get more donut than if I have 2 7ths. This is more. The 5ths, it's not about the 5 compared with the 7 necessarily. It's also connecting those numerators. I only have 2 on both. So that's a big, big clue. 5ths are bigger pieces. 7th are smaller pieces. So if I have the same amount, I want the same amount of the bigger pieces to give me more. Okay? All right. Last one here. In parentheses. Okay? Here on this side, I've got 3 plus 15/12. Now, on this side, and still I've got a 3 times. On this side, I've got 3 times 3 in parentheses. I have to solve that first. So what's the value of this 15/12? What is the value of the 15/12? Very much key here. So let's just think in terms of what am I doing when I turn the improper fraction into a mixed number? It's more than 1, okay? 12 goes into 15 a whole time with 3 left over. So I can just say, let's just say it's 1. Okay, it is more than 1, but I'm just rounding. I'm doing mental math, remember? So if I have 3 plus 1, I end up with 4. So I have a 3 times 4 over here, roughly. Don't actually solve it, please. And over here, let's pretend, well, that's about 1. But what do I have? I have about 9 plus 1. 3 times 3 would have to be solved first. So I end up with a comparison of a 3 times a 4 or a 9 plus a 1. So my overall, and I'm not actually solving it, and I know some kids are going to do it. They are going to solve this exactly out, and they're going to say, well, I calculated it, and I got this. And, that's nice, but you have to recognize that you can also round, and you can do it without calculating, and you can say, this side is bigger. If I was rounding, 12 is bigger than 10. I can see that, when I multiply, I'm going to get a bigger number. And it's not always like here I'm multiplying first, but you're just adding 1. Okay? And so you're only multiplying the 3 times 3. So anyway, for your written explanation, you can just kind of write out like 3 times 3 equals 9 plus about 1. Okay? And then for the other side, it's going to be 3 plus about 1 times 4 is about 12. And so I should still put the is about 10. Okay, and so you just want to get to those approximate rounded answers. It's supposed to be mental math without calculating. You're supposed to explain your thinking. So you can think about these in this way without actually solving them. Okay. Finally, number 5, kind of a big guy. This is kind of a mean lesson. They just throw everything at you, including the kitchen sink. Okay, 5 A, B, C, D, E. Lots of stuff here. Good data, good information. We're going to make a line plot down here on D. So let's start figuring out this information. Colette bought milk for herself each month and recorded the amount in the table below. For A through C only, write an expression that records the calculation described. Remember word form, you have to figure it out. Then solve to find the missing data, the gaps, in the table. And then we'll just continue with D and E. Now, she bought 1/4 of July's total. Where's July? In June. So if you want to figure out June, which is missing, that's where we're going to start. I have to find 1/4 of July. That's a whole number, so put it over 1. Now this one's pretty easy. You can cross cancel or you can multiply straight across. Let's multiply straight across, and you can have 2/4 and 1/2. Now why am I going to put both of them here? I'll tell you in a few minutes. I like simplest form because it helps me understand. But I also am noticing that 4 is a denominator here. And so if I can keep things in fourths, it might help you later. Hint, hint, do it. Okay, so she bought 3/4 as much in September. Trying to find this one now, okay? She bought 3/4 as much in September as she did in January and July. January and July. January and July. Combined. She bought 3/4 as much, 3/4 of the total of January and July, and she bought 3/4 of that in September. Okay, it's just, I know it's hard, but just try to follow along and look at the language. 3/4 as much would be 3/4 of the total. Now, if I have 3 and 2, put it in parentheses. We have to solve this first, okay? So 3 plus 2 is 5, and then we're going to multiply that by 3/4. If you would like to not have to rewrite it, just put 5 over 1. Then there's nothing to cross-cancel, or if I shift the numerators or denominators around, nothing's going to change. I'm still going to get 15 over 4, which can be turned into a mixed number, and I like having fourths here. Okay, so 4 fits into 15 almost 4 times, but not quite. 3 and 3/4. And this is for September. Okay, next. And we have a 4 as a denominator, so that's going to help us. In April, this is our last one for the chart. In April, she bought a half gallon less than what? Twice as much as she bought in August. Twice as much as August. August is only 1, but we still have to get twice as much as that. And she bought a half gallon less than that. Now here's the real trick. Do you know where to put the half gallon less? Okay. I know the words and the numbers are right here in the front of the problem. But if you have to take this away, then it has to go here. Very important to set it up properly and put the 1/2 after the twice as much. And that's why we're doing this, is so that you can learn about the language and how it connects to the order. So solve parentheses first. 2 times 1 is 2. 2 minus 1/2. You guys can do that. 1.5. And so this is the April amount. Now, because I mentioned earlier that having fourths as our denominator may help us, let's just convert this 1/2 into fourths as well. So keep the 1 the same. And I want fourths instead because it's going to help me with my line plot. So 2 times 2 is 4, so 1 times 2 is 2. 1/2 equals 2 fourths. All right. They throw this out there like, oh, it's so easy and you're such a pro. Let's just make a line plot. Display the data from the table in a line plot. Oh boy. Put a line. This is from Module 4, Lesson 1. Haven't seen one in a while. Don't be afraid. Okay. When you look at the data, what do the numbers look like? Well, they look like small numbers. I have some that are fractions. They are just barely above 0, so I want to have 0 on my number line. And they don't go up super tall, super high. I don't have anything above 3 except 3 3/4. I don't have anything higher than 4. 7/4 I could turn into a proper mixed number. It's not even 2. It's 1 3/4. So I can look at all my data in here and say, yep, 4 would be my max amount. So put a line in the middle at the beginning and at the end. 0, 2, 4. Put your odd numbers in the middle of your 2 halves. 1 and 3. So you have a 0, 1, 2, 3, 4. Remember that line plots are simply a number line with data above it. What kind of data are we going to put for our measurements? Well, I need to look at each one hole in 4 parts. That's what I was doing when I was making fourths, was I was thinking ahead. There goes the lights, but I still have a light on. Yay. I was thinking ahead to how many pieces we needed to have on our line plot. And since everything can be equivalent in fourths, I went ahead and did that. Now we have our line plot. It's all just a number line in fourths. And I can plot my data. Now, you do not put numbers on here. The number line those are the numbers. You put X's on a line plot. So let's start from the top, and we're just going to check them off as we put them onto the number line. So if I have 3, that was the amount in gallons. This is going to be basically, it's gallons. Then I have 3. So right above the 3, put an X. Okay, that's one measurement. Then in February, I have a 2. No fractions, put an X over 2. Then in March, we have a 1 1/4. So where's 1 1/4? It's 1 and then a 4th. Okay, done, done, done. Here's where it's nice to have this equivalent. If you understand that 1/2 is 2/4, you're fine. You can just leave it like that. And so 1.5 is halfway through. That's April. In May, I have 1 3/4. In June, I have 2/4. Now it's not even 1, so go way back down here. It's not past 2. It's a baby number. It's fraction, less than 1. 1/2 or 2/4. Then in July, I have a 2. Now, if I already have an X there, you stack it up. In August, I have a 1. That's the only one on 1. In September, I have 3 3/4. That's our biggest amount. 3 1/4, 2/4, 3/4, X. And then check, 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 all done. And then we have 1/4. Ooh, look it's the tiniest one of all. Done. Now your line plot is done. So you take the data and you put it on your number line. Just put X's where those amounts go. And finally, how many gallons of milk did Colette buy from January to October? First, click subscribe, then we'll solve this problem. We have to add up everything from January to October. So we're going to take all these whole numbers and fractions, and we're going to put them in a big old string of numbers, and we're going to add them up. So 3 plus 2 plus 1 1/4 plus, I'm going to use all the common denominators, 1 2/4 plus 1 3/4 plus 2/4 plus 2 1 3 3/4 and 1/4. So you can always, when you do it this way, you can check and make sure you have all the right number of months. This would be a big, long expression. And sometimes I'll do like small groupings so that I have smaller amounts. It can make fewer errors because you're adding small bits and you won't forget a big string of numbers. So you can do like groups of 2. So say 5 here. And it doesn't even matter if you have improper fractions. We're going to add them all up anyway. The whole numbers together, that's 2. Numerators, 2 plus 1 is 3. 1 with nothing else is 1. 3 plus 2 is 5. Don't worry about it. Just keep going. 3 here. And then 3 plus, no whole number, but 3 plus 1 is 4/4. Now we've got less data to clutter your mind, and it makes the whole numbers kind of stand out. So now we can just add the whole numbers. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you can now simply add the few numerators you have left. It's only 3 instead of a whole string up here. So 5 and 3 is 8, 9, 10, 11, 12 over 4. And then all of a sudden, it's really, when you break it down, so easy. 12/4 is equal to 3. And I have 14 plus 3 for 17. And how do you label it? Not bananas. It's gallons of milk, right? Milk. There we go. So that is how I do it, and I hope that's been very helpful and instructive. And I will see you guys on the next video. Ta-ta for now. Bye.